All right, everybody. Thank you again for coming. This is Mr. Zawacki, and what we're going to talk about today is what you see is your DBA, discussion-based assessments. This is a review for that, what to expect, how to do it, and what you're going to study for as well. So first of all, what is a DBA? It's an oral exam, which you and I speak over the phone or in person. It includes about 5 or 6 questions in general. They cover the main topics from the module you are working in. Also, most of you already know this, but you are allowed to use the notes that you have accumulated over the module. But you shouldn't be clicking through the lessons. That's not really good practice for a DBA. But you are allowed to use all the notes you took. That's what you should use on everything anyways to help you out. Answers, they should still be in your own words. So you shouldn't really read things word for word, but kind of just, understand it and put it in your own words. It can range from 30 to 50 points. Your first DBA, if you're in biology, is 30 points. If you're in anatomy, it's 35 points. So they're pretty close. And when finished and if passed, you'll go to the assessment and type in the comments box the date and time of the DBA and 3 to 5 sentences summarizing what we talked about. So that's what you type in the student comments box. So I know each class is a little bit different. You guys are going to put the date, time, and just a couple sentences about what we talked about. After the DBA is passed, I can also give you the password for the module test, which will be given to you once the DBA is passed. You will see a regular and an honors module exam. You guys are only responsible for doing whatever level you are in. So if you're regular, just take the regular exam. If you're honors, just take the honors module exam. So does anybody have any questions about DBAs? Any specific questions about that? And Francesca, no. If you're honors, you'll only take the honors module exam. If you're regular, you will only take the regular the regular exam. The main thing there, if you are honors, you'll do both regular and honors assignments, but for the exams, like the module exams, you'll just do honors. So hopefully we're all clear on that now. All right, so for biology module 1, here are your topics. We're going to talk about these in the next couple slides. You got to know science versus pseudoscience. You got to know the steps of the scientific method. There are 6 of them. Those are live lesson 2 weeks ago. You need to know how to identify variables, the dependent variable and the independent variable at least, for sure. You also need to know the 4 macromolecules. That was all 1.02. And then you need to know early Earth conditions, like what Earth was like when the first organic molecule came on. And then you should be able to talk about a hypothesis, at least one, of how the first organic molecule was made on Earth. So these 3 are 1.01. This one is 1.02. And then the last 2 is 1.03. That's where the questions come from. Just the 3 lessons that you did in Module 1. So first of all, science versus pseudoscience. So with that, science and pseudoscience are definitely very different. Pseudo means fake. So we got science and then we got fake science. Science, we know. It's just a body of knowledge based on the study of the natural world. The whole point of science is to answer questions about the natural world. If you have a question that can be answered, that's about science. It's based on the scientific inquiry. It's a creative process, but it's based on observation and experimenting. So real questions, real answers. That's science. Pseudoscience is more about, it may sound science-y, but it has no rigorous testing and data to back it up. Like, for example, astrology or horoscopes, or tarot cards or palm reading. Many people believe in that, that people born on certain months have certain characteristics about them. Well, that's pseudoscience because there's no hard data that backs it up. You can't really put that in the scientific method. Certain things about some sort of diets, infomercials, magnet therapy, copper therapy, religion, art, many things like that are all pseudoscience because they're based more on opinion, and that's why they have that. So make sure you're able to discuss the difference between science and pseudoscience, along with some examples that we just went over. All right, so here's the scientific method. And remember, there are 6 steps. You're going to have to tell me these 6 steps. First is ask a question. You always have to have a topic. Then you're going to do background research. You're going to look up information about the question and hopefully come up with more information about it. Then once you're really good on the topic, then you can make a hypothesis of what you predict is going to happen. After that, you're going to want to prove it, right? So then you test your hypothesis by doing an experiment. This is where your variables are also found. So once you're done with the experiment, you're going to have all this data. So you have to organize it, and you're going to have to analyze it by making data tables or graphs or tables or something that organizes your data where somebody can look at it and make sense of it. And then the final step is your conclusion and stating about your hypothesis. That's the last step, your conclusion and communicating your results. So make sure you know these 6 steps in order for the DBA for sure. So does anybody have any questions on science and pseudoscience and the scientific method? Anybody have any specific questions, or are you good to go on that for the DBA? Yep, you have any questions, feel free to ask them. I'll give you guys about 30 seconds more. That's a good question, Asia. A lot of people have found archaeological evidence that supports their religion. However, it doesn't go into science of the process of science. Like I said, some of these things are very believable, and many people believe in them all around the world. But it's hard to test that versus somebody else's opinion. So if you're testing opinions versus opinions, that's where it gets into pseudoscience. It doesn't mean that these are all fake topics. It just means that you can't really test them in the scientific method. And it turns into science if you turn into the archaeology part of it. So yes, you could slightly turn it into that. Like, for example, one show I watch is Expedition Unknown with Josh Gates on the Travel Channel. And he has discovered evidence that supports writings of religious texts from the past. So that right there, the archaeology behind it, discovering it and trying to connect it is science, yes. But some of the other things that don't have any data backing it up, that's where it gets into somebody's opinion versus somebody's opinion. So yeah, it can go either way. But yes, good question. All right, so those were those 2, with science, pseudoscience, and also the scientific method. Then you need to know about variables. So this is everybody's part of their participation. I want you to tell me the independent variable the dependent variable, and at least one or two constants. So look at this up here. It says, for an experiment, John has written this hypothesis. If the number of sharks along the beach is related to fishing boats dumping bycatch, that just means dumping what they're not keeping, then if the number of fishing boats increases, the number of sharks in the area will increase. So I want you guys to tell me the independent variable, the dependent variable, and a couple constants. And for the DBA, I'm going to give you an example experiment, not this one, but something similar to this, and you just have to tell me the independent variable and the dependent variable. So you want to think, for the independent variable, what are they purposely making different? Dependent variable, what are they measuring as a result? And constants, what are they keeping the same? So just looking through some, Colin, you are good. Good job. Yeah, Nathaniel, that can technically be a constant. Emma, number of fishing boats. Yep, that's the independent variable. Danielle, good job for independent and dependent. Ciara, yeah, good. That's a good constant. Isabella, good. Good job. Jesus, Joshua, yep. Yep, good job, Helen. Good job, Asia. Yeah, good job, Francesca. That would be a definite constant. Taylor, Emma, yep. Good job. Hunter, good. So yeah, guys, what you're changing on purpose is the independent variable. So that is going to be the number of boats. That's what they say. If the number of boats increases, so they can change that around, right? So that's the independent variable. They're going to change the number of boats. Dependent variable, what are they measuring? Well, they're going to see how many sharks, the number of sharks that are around. Good job. And then constants, there's many things. You got to have the same beach. You got to have the same area of water. You got to have the same type of day. You have to have the same method of bycatch. You have to have the same number of bycatch per boat. So everything else has to be the same. So yes, independent variable, just make sure you know how to identify it. It's the only difference. Dependent is the data, and then constants are things that remain the same, like the beach or the area or the people working on the experiment. Good job there. So that's all 101. Here is 102, the 4 macromolecules. This was last week's live lesson if you were here. Nothing new. This is just review. Every single thing on here is review from last week. And if you can memorize this page, I guarantee you'll be good not only on the DBA, but also the test. First of all, they are all organic, which means they all contain carbon. See? Carbon, 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 carbon. They are all made up of smaller pieces called monomers. Carbohydrates are made up of monosaccharides. Lipids are made up of triglycerides. Proteins are made up of amino acids. And nucleic acids are made up of nucleotides. Those are all monomers, which are the building blocks or the pieces of the macromolecules. We also know this from last week. We went over this pretty in depth. They can be built by dehydration synthesis, which means remove water. They can be broken down or reversed by hydrolysis, adding water. Think of like damaging or breaking apart a sandcastle. All you got to do is add water and it'll break apart. Same thing with the macromolecule. And if you want to build it up, you remove water and you can mold it and form it all together. So that's just a good idea, good way to think about it. All right. So also memorize this bottom table. Carbohydrates, we know that we just went over the building block. It contains CH and O, and they do short-term energy. Lipids also contain CHO, but they do long-term energy, insulates the body. All of your cell membranes are made up of phospholipids, so that's what lipids do. Proteins contain CHON. They can build muscle. They can act as an enzyme. That's a protein that helps reactions in your body. They help carry oxygen, like hemoglobin on red blood cells. They can also fight infection as well. And then nucleic acids, they contain the most elements, CHONE, and they're your genetic material. Can anybody tell me the two examples of nucleic acids? There are only two. What are the two nucleic acids? Good job, Isabella, and Joshua, and Helen, and Francesca, and Colin, and Marcus. Good job. So that's your genetic material. So are we all good on 102, or do we have any questions? You need to know the four statements up top, and you need to know that table. If you can memorize this slide, you're 100%. And the good news is this will all be recorded as it is right now, so you guys will have this as an extra study piece if you need it, but hopefully you're taking notes on this as well. All right, I'll pause for like 30 more seconds to see if there's any other questions. Yes, those letters are elements. So C is carbon, H is hydrogen, O is oxygen, N is nitrogen, and P is phosphorus. And I will send out, I just got actually last week's recording, so I'll send out the last 3 recordings all in an email probably by tomorrow. All right, so that's 102. The last lesson is 1.03. And like I said, you need to be able to talk about how Earth was like when the first organic molecule came about on Earth. And that kind of deals with this statement here. First of all, there was little or no oxygen, mostly carbon dioxide. So there's a lot of carbon dioxide. There was water vapor, so there was like water in the air, like humidity, but there was no real water like on Earth in terms of oceans yet. There was a lot of nitrogen. There was lesser amounts of the other 3, but the main 3 were carbon dioxide, water vapor, nitrogen, with very little oxygen. Also, it was constantly being bombarded with volcanoes, asteroids, explosions. You know, this is the very beginning of Earth. Earth formed 4.6 billion years ago, but 4.2 billion years ago was when the first piece of a cell was supposedly came about on Earth. And these scientists, Miller and Urey, they suggested how mixtures of the organic compounds may have arisen from simpler compounds. So they think like, for example, A colliding with B, so inorganic plus inorganic can maybe lead to AB, which is your first organic molecule. That's all they think that happened. They think there's just a random collision and, you know, combination of elements that collided with a little help from heat, a little help from radiation, and it created organic molecules like you see today. The RNA world hypothesis proposes that RNA existed by itself before DNA. And from this simple RNA-based system, several steps could have led to the DNA directed protein synthesis. So what I'll show you next are a couple of those hypotheses. One of the hypotheses is right here. Miller and Urey showed in the lab that you can combine different pieces to create organic molecules. That's what they did, and they think that happened on Earth. That's one of the hypotheses. The other one is the RNA world hypothesis, and that's right here. Step one, you get RNA forming from inorganic sources. So this is inorganic, this is inorganic, and it could lead to this organic substance. Step two, it can make more of itself. Step three, they can also make proteins from RNA as well. So now you have RNA, you have proteins, you have ribosomes. All you need to do is have something that holds it all together, and that's where your lipids come in with the cell membrane in step 5. So RNA codes both DNA and protein, and you have it surrounded in a lipid membrane. And now RNA can turn into DNA, very simple, which we'll show you in a few chapters. And proteins are also made from RNA as well. So they think with the RNA world hypothesis, RNA was made, by heat and radiation and combination of elements, and that led to proteins, because RNA can make proteins, and it also led to DNA, because you can make DNA from RNA as well. And then you just surround that all in a cell, like a cell membrane, and you got your first prokaryotic cell on Earth. You got your first living thing on Earth, right there, step 5, first living thing. And then from there, it can evolve to form bigger cells with more things, and that's how they believe with the RNA hypothesis that life came about on Earth. So it's one of these three. It's either, inorganic molecules formed an organic molecule with Miller and Urey, or RNA came first in the RNA world hypothesis, or an asteroid lands on Earth already containing all of that, and it just took off from there. That's called, it has a couple different names, but it deals with just an asteroid landing with RNA already on it. So one of those hypotheses we just have to explain. So does anybody have any questions about 103 in terms of what Earth's early atmosphere looked like? And one of those hypotheses about the first living molecule on Earth. So pause for about 30 more seconds. If anybody has any other questions? So just backtracking, yep, right there. Make sure you guys know these 6 questions. These are the 5 to 6 questions that will be brought up for sure. And science and pseudoscience, scientific method steps, identifying variables, the 4 macromolecules, early Earth, and then the hypothesis. And then Hunter, I understand about it's not really based on opinion though, because they've proved it that it could happen in an experiment. So a little bit more than an opinion, it's a hypothesis. So it is being tested and supported, so it is one step further than an opinion. Otherwise it would just be pseudoscience. But anyways, guys, just make sure you know these 6 things, and you'll be all set for the DBA for biology. Now, if you guys are in here for anatomy, these are your 6 topics. You need to know the words anatomy versus physiology. You should know the directional terms. This is 1.01. Directional terms are 1.02, like anterior, posterior, superior, inferior. You should know the third one with the 4 types of tissues. This is 1.03. You should know the skin, the dermal layer of your skin, in some ways that it can regulate body temperature. axial and appendicular skeleton, be able to tell me a couple bones in each skeleton. And then compact versus spongy bone, be able to explain the difference between those two types of bone. So I will leave this up for anatomy. If nobody has any other questions for biology, you guys are all set to go. So thank you guys again for coming. Inez, Francesca, this is kind of just a combined, because I do have, I think, a handful of anatomy students as well. So we did biology first, so if you guys don't have any questions, you're free to go. And we're just looking at anatomy now to see if anybody has any questions for that. So thank you guys again for coming, and hopefully we'll see you here next week. We're going to talk about water and how it's way more important than you think. So thank you guys for coming.